SwiftUI and Core Data were introduced almost exactly a decade apart. SwiftUI in iOS 13 and Core Data in iPhone OS 3. It's so old, it wasn't even called iOS back then because the iPad hadn't been announced yet. But despite this large gap in time, Apple's put a lot of work in to make these two powerhouse technologies work together beautifully. Almost to the point where they feel like they were always designed to work that way. First, the basics. Core Data is what we call a object graph and persistence framework, which is a fancy way of saying we can define objects, give properties to those objects, and then read and write them from permanent storage. On the surface, this will sound a lot like codable and user defaults, but it's much, much more advanced than that. There is effectively no limit to how much data you can store with Core Data. Plus you get things like sorting, filtering, and more. Plus, when you need to really lean on it, you get more advanced features like undo and redo support, for example. It's all there waiting for us, along with data validation and a lot more. Anyway, in this project, we'll only be using a tiny slice of Core Data. Just a little sampler. We'll expand on it soon enough. I try and give you a little taste of it nice and early. Now, when you made your Xcode project, I actually asked you not to check the box use Core Data. That's intentional. Because, yeah, that box gets a few boring setup things out of the way, but also brings in a whole bunch of example code that you just have to delete. It's just annoying and pointless. So please don't check that box. So instead, you're going to learn how to set up Core Data by hand from scratch in a blank project like this one. And it takes 3 steps. Starting with us defining the data we want to use in our app. Now, previously, we defined data like this. We say there's a struct called student, for example. We'd say it has an ID, UUID, and a name, string. However, Core Data does not work this way because it needs to know ahead of time all the data we want to have in our program, plus what it contains, and also how it relates to other pieces of data. For example, a school might have many classrooms, and a classroom might have many students. So they all link together. Now, all this is contained inside a new file called a data model, with a new file extension called XC data model D. Let's make one now. Press Command N, make a new file. Don't choose SwiftFile or SwiftUI view. Instead, look for Data and choose Data Model. Press Next and call this thing bookworm.xcdataModelD. Then press Create. It'll be created and it'll open up this little editor here, which is a data model editor just for this purpose. Here, we define our types. They're called entities. Then we create properties on those types called attributes. And it's Core Data's job to figure out at runtime the actual database layout so we can use these entities and properties at runtime. Now, for trial purposes, press Add Entity now, make a new entity. Then double click it up here and rename it to be Student. Next, click the plus button underneath Attributes here. We're going to add 2. One is called ID, which will be a UUID. And another one called Name, which will be a string. There we go. And that tells Core Data everything we have to know to create students and save them. So we can now proceed to the second step of setting up Core Data, writing a little bit of Swift code to load that model and prepare it for us to use. Now we're going to write this in a few small pieces so I can explain what happens as we go. First, press Command N, make another new file, choose SwiftFile this time, and name this thing datacontroller.swift. Then press Create. Now, go ahead and add an import for Core Data above the import foundation. I should say that can go anywhere. You can put it here, but come on. Alphabetical order is sort of staring at us. Why not take that? And inside here, we're going to make a new class called DataController. And this thing will conform to the observable object protocol so that we can use @stateObject with it. We want this thing to be created when our app launches and then stay alive for as long as our app runs. Now inside here, we're going to add a single property of the type NS persistent container. This is a core data type responsible for loading a model and then giving us access to the data inside. From a modern perspective, this is going to sound quite strange, but the NS in NS persistent container comes from Next Step, which is an operating system made by a company Steve Jobs produced in the late 90s. It was acquired by Apple in 97 or so and merged into Apple and became the foundation, quite literally, the foundation for things Apple made in the future. Core Data has some really old foundations. Anyway, we'll add one of these now. We'll say let container be an NS persistent container with the name being Bookworm. And that refers to our XE data model D file, right? We're telling Core Data to use our Bookworm data model for its container. It doesn't actually load it. We'll do that in a minute. But it does prepare Core Data to load it. We're ready to do so now. Now, data models don't contain the actual data. They just contain the data models, the definitions of properties and attributes and entities and relationships and we made a few minutes ago, right? To actually load things, we got to go ahead and say, please try and load your data. And it will read the saved data from disk, from a sort of private storage area called the documents directory for our app. It'll load that back out, the real live data for us to work with. And that's entirely possible that might fail, right? That might, maybe the data's corrupt, for example. But if it does go wrong, at this point in your Swift career, there's not a lot you can do. You can show an alert and say, sorry, data's bad. Try and restart the app. It doesn't happen often, if indeed ever, but at this point, there's not a lot you can do. Anyway, we're going to write a small initializer in here, in it. And all we'll do is go ahead and call load persistent stores when our controller is created. So we'll say container.load persistent stores, and then it'll pass us a description here, and error in. And if any error happens, if let error equals error, all we'll do is say print core data failed to load and print the error out. Error localized description. Like that. And that is our entire data controller. It's really, really simple. So the final little step here is to make an instance of data controller and then send it into SwiftUI's environment to say, use this thing, please. Now you've met at environment previously. We used it in an earlier project to dismiss our view. There's a dismiss action in there, right? But it also stores other useful things like our time zone, whether we're in light mode or dark mode, and a lot more. And this is relevant to core data because most apps only use one core data store at any given time. So rather than every view try and make their own store, try and read data independently, instead we make it once when our app launches and then store it inside the SwiftUI environment. We inject it into the environment so everywhere else in our app can use it. To do this, go into our bookworm app.swift file and then make an instance of our data controller. We'll say at state object, private var, data controller is a data controller. Like that. That makes a data controller and keeps it live the entire time thanks to at state object. And now we can put it into the SwiftUI environment by adding a new modifier to the content view like this. .environment /dot managed object context data controller .container view context. Now, you've already met data models. That's this thing over here. The definitions of the entities and attributes we want to use in our code. And you've met NS persistent container, which is the actual data being loaded and saved to the device. That's what it's doing here. Well, you just met the third piece of the core data puzzle, a managed object context. These are effectively the live versions of your data. When you load data and you change data somehow, those only exist in memory until you specifically say, I'm done now, write it back to the persistent store, to the iPhone's SSD, whatever you're using, right? So the job of the view context is to let us work with data in memory, which is of course much faster than working with it on disk all the time, always reading and writing objects. So we'll load it once, work with the memory, modify as much as you want to, and then write it out only when you're ready. Of course, when you're ready, you still have to write it out. You can decide not to. You could say, actually, forget those changes, discard them, don't write them. But if you do want to write them, you say save. So at this point, we've made our model here. And we prepared it for use of SwiftUI by loading it and then injecting it into the environment here. There are still two pieces of the puzzle left: reading data and writing it too. Now, reading data with Core Data is done with what's called a fetch request. We describe what we want, how it should be sorted or filtered or whatever, and then Core Data sends us back all the matching data for us to use. Now, we've got to make sure this fetch request stays up to date over time. So as student objects are created or removed, our UI stays synchronized. Now, SwiftUI has a solution for this, and surprise, surprise, it's another property wrapper. This time it's called @fetchRequest and takes at least one parameter describing how we want sorting to happen. It has quite a specific format. So let's start by going to Content View and adding a new property now. We'll say there's an @fetchRequest, sort descriptors, empty array, var students, fetched results, student. Like that. So, if we break this down, we're saying make a new fetch request with no sorting. Just give it to me in a random, whatever you feel like order. Then put it into a property called students with the type fetch results of student. And from there, we can go ahead and use students like a regular Swift array. But there's one catch, as you'll see. I'll say in our body there's a VStack, the list of our students, and one student comes in. Then we'll do text student.name, nil coalescing, unknown. Like that. Did you spot the catch? Yes. Student.name is an optional. It might have a value, but it might not. And this is one area of Core Data that will greatly annoy you because it has the concept of optional data. It knows what optionals are. But it's an entirely different concept from SwiftUI's optionals. They're two different things under the same name, optional. They mean different things. If we said at Core Data, this thing can't be optional, like name can't be optional, which you can do. You can say name cannot be optional, it must be required. It will still generate optional Swift properties. Student.name will still be a Swift optional, even though Core Data has non-optional. Because all Core Data cares about is that the properties have values when they are saved. So they're optional in Swift for the entire lifetime, no matter what you do. But when you press save, they must have a value in order to work. Because saving will check. Oh, this is not optional. Has it got a value? No, refuse to save. And so it has optionals, but they mean different things, which is really annoying. You've got to do nil coalescing everywhere, as you can see. We're going to do a better workaround for this in the future, but it's enough for now. You can run the code if you want to. There is no point because there's no data. We're going to fix that by adding a new button to our VStack that will create a new random student whenever it's pressed. But to do that, we first have to add a property to access the managed object context from our SwiftUI environment. Now I'm going to back up a little bit here because this stuff matters. When we made our student entity up here, what happens behind the scenes is, inside Xcode, is Core Data will make a class for us. It'll synthesize one automatically, which inherits from a parent class called NSManagedObject. Now you can't see this in your code by default. It's made for us automatically, just like CoreML made a model from its machine learning model, which is great. But they're called managed objects because Core Data is responsible for looking after them. It loads them from persistent store and writes changes back to us, back to persistent store as well for us. Does a whole thing for us. All these managed objects live inside a managed object context, one of which we made earlier when we had our data controller. We put it into the environment here. And as soon as we place it into the environment, it was automatically used by SwiftUI. In our content view here, we have a fetch request. We didn't say load that from bookworm.xdataModel. It doesn't care. It'll look in the environment for the current managed object context and use that for its loading and saving. Anyway, when it comes to us adding and saving students, we've got to access the managed object context. This is another way we'd use the @environment property wrapper. We can say, give me your context, please. So we'll say @environment /dot managed object context. There we go. var MOC, because it's a lot to type. And with that in place, the next step is to add a button below our list that generates random students and saves them in the managed object context. We'll assign a random first name, a random last name, so you can see them more easily. We'll say there's a button called add. And inside there, we'll start with two arrays, one for first names, one last names. So first name is an array of, let's do Ginny and Harry and Hermione and Luna and Ron. And then let last names be Granger, Lovegood, Potter, and Weasley. And now we'll choose a random name from both. Let chosen first name is first names, names, capital N, dot random element. And then let chosen last name be last names dot random element. Now, inevitably, some folks will see this force unwrap here and complain, how dare I have a force unwrap. We've literally just made the arrays right here and they are constant. It's perfectly safe. It will always succeed. If you hate that, fine. Nil coalesced, anonymous, it's down to you. Anyway, now for the interesting part, we're going to make a student object here using the core data class that was made for us. It was synthesized for us. This has to be attached to a managed object context, so the object knows where it should be stored. We can then assign values to it, just like we do with a struct. So we'll say, let student be a new student with the context of our managed object context, mock. And our student.id is a new UID, and student.name, and I'll just do string interpolation, chosen first name, and then chosen last name, like that. Finally, we're going to ask our managed object context to save itself, which means it will write out its changes to persistent storage. This is a throwing function because in theory it might fail. In practice, nothing about our current code has any chance of failing, so it's not going to be a problem. But if we had said, oh yeah, name is not optional, and we hadn't provided a name, then saving would fail. Anyway, here it's going to work. So we'll just say try ? mock.save. Ignore any errors because there'll be no errors. And at last we can press Command R to build and run our code and try it out in the simulator, all being well. Hopefully we should see a list of information. Let's find out. There we go. Some students I added earlier. And you press add and see your own ones jump in. And they'll appear in random places because there's no order to them. They appear where they feel like, realistically. They'll just slide on in each time. And as you saw when you quit and relaunched the app, they'll be there from the previous run. It's saved to permanent storage. It's not going to go anywhere because Core Data is looking after them for us. So you might think, this is a lot of learning for not a lot of result, right? But you now know what persistent containers are and persistent stores. You now know what data models are. You now know what view contexts are and much, much more. And you've seen how to save stuff and how to create fetch requests. There's a lot. And we're going to look at Core Data more in this project, but in a later project too, in the future. But for now, you've come a long way. That was the last part of the overview for this project. And so I partly want you to roll back to an earlier version of the code. So content view, go ahead and just Command Z a billion times to undo it all. It's all going to go away. None of this is wanted. Oops, daisy. That can all go. There we go. Boom. Okay. That's gone. But make sure you go into the data model and remove the student as well. So select the entity and press delete or backspace. Bang, gone. Please keep the model file though, and keep all our data controller. That is still good. So leave the controller alone. Make the model file exist but empty. Reset content view and leave the Bookworm app alone too. That injects the context into our SwiftUI environment. We're using these things in the real project.